We think so. Let's say we want to prove that the square root of n, when we take the limit as that n goes to infinity, is also equal to infinity. Well, for n, for some, for that n that goes to infinity. Well, a way you can do that is basically we can take a real number k, all right, some arbitrary capital Case k in reals. And then Archimedean property says that for any real number, we can find a natural number that's higher than that particular chosen real number. So there also exists, so I take that, and then there also exists some n inside, capital Case n in natural numbers, such that n is, let's say that n is actually bigger, strictly bigger than even k squared. K was a real number, k squared is 1 as well. And we can always find a natural number higher than a chosen real number. And now we can also consider some lowercase n in naturals that ranges from that capital Case N onwards. And what we'll have is, by the way, I can also transform this thing that says that the square root of capital Case N is strictly bigger than absolute value of k, and absolute value of something is higher or equal to that thing without the absolute value. This expression is already very useful, because if we take some natural number yet bigger than that already big capital Case N, well, we'll have that natural number, lowercase n, will be higher or equal to, its square root will be higher or equal to the square root of the uppercase n, alright? Because lowercase n ranges from capital Case N onwards, and that we knew was strictly bigger than k by this chosen relation to k squared, and that's higher or equal than k itself. But we have this strict inequality, and this strict inequality in this chain of inequalities relates the lowercase n square root to k. So for any taken k from real numbers, we can find that the square root of n is higher than that, indeed strictly, all right? We have this.